All right, welcome back. This is at Just Mr. Jones, and today we are going to talk about chapter 0.6, which is rational exponents and radicals. So what is rational exponents and what are rational or radicals? So first, let's kind of go back over what a radical is. Okay, so that's the radical symbol, often known as a square root, but it is more than just a square root. So you have two numbers here with your radical. The sign's actually called the radical. This is called the radicand. And this up there is called your index. Okay, now with rational, just meaning fractional exponents, okay, we can also have a number, an exponent in here right there. Let's just call that E. So if I want to change between this radical and a fractional exponent, it will look like this. So you will have A to the E over B. Okay. I refer to it as an inside-out fraction. So this is inside, meaning it is inside the radical. And I refer to this one as outside. It's right there. So for example, let's say we have the square root of x. Okay, if there is no number here on your index, or I call it the shelf, it is a square. It is a 2. It's a square root. Okay, so if I were to turn that into a fractional exponent, the inside number is a 1 and the outside number is a 2. So the half power and the square root are the exact same thing. And those are kind of the things that we're going to talk about here in 0.6 today. We do have some domain restrictions on these. Okay, and I want to kind of just outline those real quick. So we can have several cases. So let's say we have an even index, and it is a variable raised to an odd power. Okay. In this case, x has to be bigger than or equal to 0. Okay, because you can't have a negative number under an even exponent. So, for example, here, let's say I have, let's just say I have the square root of -2 to the third. Okay, well, -2 to the third is -8. The square root of -8 is an imaginary number, and we can't have that. Okay, so x values have to be bigger than or equal to 0. Okay, so the next one would be an odd index, and x to an even bound. Okay, in this case, okay, we want the absolute value of x when you're simplifying that. Okay, because it has to be a positive number. Okay, under the radical, it has to be a positive number. Okay, so then have odd radical x to the odd. And this doesn't matter. Doesn't matter what value you have for x or anything when you simplify. They can be negative in that case. Okay, and then even doesn't matter either. Let's say even. Okay. We're also not worried about those kind of numbers with that. Okay, there are some property rules that we want to go over, and the first one kind of goes back up to what we just said with that, and that is that the square root of x is the absolute value of x. Sorry, the square root of x squared, okay, is the absolute value of x. So make sure when we're reducing and simplifying that we remember the absolute value signs. Okay, so radical a times radical b is radical a times b underneath. This is only true if the indexes are the same. So maybe I'll put an n, and all the indexes have to be the same. We can kind of do the same thing with division. So if I have n radical by the nth root of b, that is the nth root of a divided by b. Okay. And then we go back to this inside out rule. So if I have a to the m over n, that is the same as the nth root of a to the m, or you can take the m on the outside of this. So you can have n a and we could have it like that. So you can't see that. All right, so okay, we cannot have a radical on the denominator. Okay, it's not proper to have that. So in order to get rid of that, we do what's called rationalizing the denominator. Okay, rationalizing the denominator is getting the radical off the denominator. So for example, I'll do two examples here. I'll do just a simple 1 over square root of 2, and let's do 2 over 1 minus square root of 2. Okay, in order to get rid of this radical on the bottom, I'm going to have to multiply it by something that will help me get rid of it. Okay, to be a perfect square. So the smallest perfect square I can think of is 4. Okay, so in this case, I'm going to have to multiply the bottom by radical 2. If I do it in the bottom, I got to do it in the top. Okay, so in the top, I'll have radical 2. In the bottom, I'll have radical 2 times radical 2, which is radical 4. Now, the radicals don't just cancel each other out. In turn, we have the square root of 4, which we know is 2. So we have radical 2 over 2. Now, my whole goal was to get the radical off the bottom and into the top, which I have. Now, when you have a binomial or something here, it changes a little bit differently, or we do it a little bit differently. We have what's called the conjugate. Okay, so we have to multiply by the conjugate, and the conjugate is just changing this middle sign. Okay, so when I multiply, I'm going to multiply by 1 plus square root of 2. And you know a conjugate. You know a conjugate from that right there. Okay. These two will, in turn, when you multiply, get x squared minus 9. So your middle terms go away. Or these x's go away and you have x squared and you have 9. So when I multiply this here, let's multiply the top. We'll just distribute. So you have 2 plus 2 radical 2. Now in the bottom, you're going to do your first and you get a 1. You're going to do your outside. You get a plus radical 2. Do the inside, you get minus radical 2. And your last radical 4. Okay, now notice here, you have plus radical 2, minus radical 2, those go away. You have minus radical 4, which is 2. So you have 1 minus 2. So really the answer is 2 plus 2 radical 2 over minus 1. Okay, so make sure we're multiplying this out and double check. Okay, steps to simplify a radical expression, or these are simply just make sure you know you're done. Okay, let's start here. So your radical does not contain a fraction. Radical, no fraction in radical. It does not contain a radical. Denominator. The power of the radicand does not share a common factor with the index. So that's just saying this. Let me see. That's saying that this power right here cannot be grouped in this number right here. Okay, and we'll see some of those examples. So radicand doesn't share common factor Okay, and then the first one was no factor in the radicand is raised to a power greater than or equal to the index. No power to power bigger than index. Okay, and we'll see what all of these mean as we go along. So let's see, that might do it here. The first question is, how do you go from a fractional exponent to a radical? I think that, I went over that. To get a radical 2 minus radical 7, and make sure you multiply that out to see it. The goal is, if you multiply by the conjugate, you will no longer have any radicals. Okay, so make sure you get that. And what makes like radicals? You may have to watch this again to see that I did go over that very briefly. There are your suggested problems. 83 is your challenge problem. And if you decide to stick with me, I'm going to go over quite a few examples of this section. So it might be good just to hang on for a little bit and continue watching. If not, we'll discuss it in class. This is at THS, Mr. Jones, signing off. All right. Thanks for staying with me. We'll just go over some examples here of radicals. So let's just start with the square root of 6 squared. We work on the inside first, so 6 squared is 36. 36, which in this case is 6. Okay, again, working on the inside here, negative 7 squared is 49. And the square root of 49 is 7. That does go back to some of the properties we just talked about, in that this right here, the square root of x squared is the absolute value. So if you wanted to take the shortcut, you just take the absolute value of negative 7 there, which is 7. In this case, the square root of x squared will be the absolute value of x. Okay, so there is no working out anything there. Okay, so we have the square root of 48x. Now, I'm going to switch to a pen here and maybe zoom in a little bit on these problems. Okay, so in order to reduce a radical, okay, we do a prime factorization tree. Okay, my index is 2, telling me I need groups of 2 when I factor this out. So we'll break down 48. That is 16 and 3. We can break down 16, 4. There's a group of 2 identical numbers, and we have 3 left over. So that's telling me that a 4 is coming out front and a 3 is staying underneath. Oh, I wrote this wrong. This should be a square. That should be x squared. Okay? And we know that the square root of x squared is the absolute value of x. So we could also break that down, x, there's a pair. Okay, so what's coming out front? My circled groups are coming out front. I have an absolute value of x, again, from this rule right here. And then underneath the radical still is a 3. Okay, 28 breaks down into 4 and 7. And 4 is 2 and 2, so there's a group of 2. I underline the ones that don't match up. That way I can't forget about them. X will become x squared, and that's a group of 2, and an x left over. Okay, now because it was an even power, an even index, and an odd power. Okay, let's go back to this. We had an even index and an odd power. At an even index, odd power. That tells me that x has to be bigger than equal to 0. So I got to put that right away. X is greater than equal to 0. Okay. This negative under here. Okay. So now this 2 comes out. I have a 2, and I have an x, and I have a radical x left over. Now you may be wondering why I didn't put the absolute value around the x. Well, because x is already positive, there would be no need for that absolute value sign. If you put it, I'm not going to count you wrong at all. Okay, you'll be fine. All right, so we got multiplication. My indexes are the same, and they're both 2. So now I'm able to multiply the stuff underneath by each other. So when we multiply 12 times 6, we'll get 72x squared. Now we'll break down 72. That is 36 and 2. And that is 6 and 6. So there's a group of 2, 2 left over, and your x squared is a group of 2. Okay, now again, we had an even index and an odd power, so we have to say that x is bigger than equal to 0. So your 6 comes out front, your x comes out front, and you're left with a 2 underneath. This right here, this x greater than equal to 0, that's your domain restriction. Okay. And this one last here. Okay, so we have odd, and we have an odd and an odd. Okay, well the thing of it is we can't have a 0 here. Okay, so we're going to say x cannot equal 0 first. Okay, now we're dividing. So we're going to say the square root of 45x to the third over 5x. All right, so then 45 over 5 is 9x squared. Okay, so now since we have an even here and an odd here, that means x is greater than equal to 0. But we said that x could not equal 0, so in the end, x has to be bigger than 0. And we can reduce this. The square root of 9 is 3. And the square root of x squared is x. And you have x greater than 0. And we are simplifying. So you've done this part before. We're just really adding in, this domain restriction stuff. Okay, that's the college algebra stuff that we're getting to. Okay, so you have 3 radical negative 24x to the 5th. We're going to break down. Now, since my index is 3, that's telling me I need a group of 3 items before I bring it out front. Okay, so if I break down 24, that'll be negative 2 times 12. We're going to bring out another negative. We'll say negative 2 times negative 6. And negative 2 times 3. So here is my group of 3 terms. I had an odd index, odd exponent. Odd doesn't matter what x is. Okay, so underline your 3 that's left over. I have x to the 3rd. That's a group of 3. And I had x squared, making a total of 5. That's left over. So what comes out? You have a negative 2. From here and here, you're just bringing one of those items out. Okay, and you have the 3rd root of whatever was left underneath, which was 3x squared. And we're finished. Okay, with an index of 4, that's telling you you need 4 groups before you bring something out. So if I break down 32, that's 2 and 16. That's 2 and 8. That's 2 and 4. And that's 2 and 2. So we will circle our group of 4. Underline the remaining. The remaining one. We have x to the 4th. And then I had 1x left over. What's coming out front? We have a 2 coming out front. We have an x coming out front, and we have radical 2x underneath. Now, what did I forget? I forgot to restrict my domain. So notice here we have an even index and an odd power. So even index, odd power, x has to be bigger than or equal to 0. So we'll say x is bigger than or equal to 0. Okay. You might keep those 3 rules handy so that you can check them out. And I needed a 4 here. My index was 4, not 2. Okay. All right. Combining like radicals. Okay. In order for it to be a like radical, it has to have the same index. Okay. So the index has to be the same, and the number underneath has to be the same. So here I have all square root of 3. You follow order of operation. You're going to take 4 minus 6. That's minus 2 radical 3. Plus 7 radical 3, and negative 2 plus 7 radical 3 is 5 radical 3. Not always will they give you your radicand to be the same, like down here. These are not the same, so we have to see, can I make them the same? Break that down to 4 and 5, 2 and 2, so there's a power of 2. So there's a group of 2, which I needed for my index. So we have 3 radical 5, 2 radical 5. So those are like. 45 breaks down to 5 and 9 and 3 and 3. So then I'm bringing out a 3, but I already had a 2 out front. So that is minus 6 radical 5. Okay, so now all of them are like. So we'll take 3 plus 2 is 5, minus 6 is minus 1. So you have minus radical 5 as your answer. Now here, if we look at these radical 10s, I have the 4th root of 10, I have the 3rd root of 10, and I have the square root of 10. Those are all 3 different values. Because your indexes are different, Okay, that was a 2. You cannot, these are not like radicals. So let's say it was radical 10 minus radical 100 plus 3 radical 1,000. Still not the same. Even though your index is the same, your radicand is not the same. So you're not going to be able to combine those. All right, so this is dealing with rationalizing the denominator. Okay, so in order to do this, we just have to make sure we get the right number of groups under the radical. So in this case, it's fairly easy. We're just going to multiply by radical 10 on the top and the bottom. So you get 2 radical 10 on the top. Now, this is 3, but radical 10 times radical 10 is radical 100, and the square root of 100 is 10. So now you have 3 times 10, which is 30. We're going to reduce. We're going to divide by 2. So that's radical 10 over 15. Now, you may be thinking, well, that's 10, that's 15, let's divide by 5. However, you cannot. This is under the radical, and this is not. So I cannot cancel any of that out. Okay, when I have 2 terms on the bottom, we're going to multiply by what's called the conjugate, which is just changing that middle sign. It doesn't matter if the radical is first or second, or if they're both radicals. You're just changing that second sign. You will not multiply by itself. That doesn't get rid of the radical. That does up here, but even then it's not multiplying by itself because we get multiplied by the 3. Okay, so you'll distribute the 5, so you have 15 plus 5 radical 2. And in the bottom, you're going to take your first, you get 9. You take your outside, plus 3 radical 2. Your inside, minus 3 radical 2. And your last, minus radical 4. Okay, so that's plus 3 radical 2 minus 3 radical 2. Radical 4 is 2, so now you have 9 minus 2. And 9 minus 2 is 7. You have 15 plus 5 radical 2. And we're finished. Okay, we can't cancel anything. If, like this, let's say we had 15 plus 5 radical 2 over 5. Now, I can reduce this more. Notice my common factor between these 2 terms is 5. 5 out of that, I get 3 plus radical 2 over 5, and I can cancel those 5s right there, and I'm left with 3 plus radical 2. Well, this is kind of nice because it gives you your domain restrictions, which is great, so we don't have to worry about that stuff. Okay, so I just need to worry about getting those fractions reduced. So the first thing I want to do is I kind of like to split it up a little bit. Okay, so we're going to work with the top, and then we're going to work with the bottom. And I need groups of 3 to come out. So we're going to say the third root of 16x5 and the third root of 81y to the 7. Now I wrote it out side by side just so we can work our way down, but I will have to stack it top and then bottom. Okay, so I need 16 broken down. That's 2 and 8, 4, 2 and 2. So there's a group of 3. And I have x to the third, and then x squared, so there's root 3. So in the top, we're going to have 2x third root of 2x squared. Okay, in the bottom, I have 9 times 9, 3, 3, 3, 3. So there's 3 3's. Okay, so then I have y3, y4. There's a group of 3. But notice I can make another group of 3 and have 1y left over. So coming out front in that one is 3y squared, third root of 3y. Okay, now, can I leave a radical on the bottom? No, I cannot. But I can't just multiply by the third root of 3y because I won't have a group of 3. So I'm going to multiply by the third root of 9y squared. Okay, think about it. 9 has 2 3's in it. That's 3 times 3 times this 3, making 3 3's. I have 2 y's here, 1 y there, making 3. So I'm going to multiply the top one by that. Okay, and then reduce. Okay, so in the top, third root, I like to multiply and then reduce if I can. So you have 2 times 9 is 18. You have x squared, y squared, over 3y squared, third root of 27y to the third. Now we know that one will reduce because we set it up that way. But I have 3 times 9, 3 times 3. There's 3 3's and there's 3 y's. So in the bottom, sorry, I'm kind of running out of room here. In the bottom, coming out front is a 3, but you already had a 3, so you have 9. You have y squared, and you're bringing out another y. So that's y to the third. Okay, now 18. 18 is 2 and 9, 3 and 3. So I cannot make a group of 3 numbers any way. Okay, x only has 2 and y only has 2, so I can't break that down. So you have x squared, or sorry, you have 2x, third root of 18, x squared, y squared. That is your final answer. Okay, coming back over here, that one was kind of difficult, and we will be doing some of those, so make sure we practice those suggested problems on that. Coming over here, we have fractional exponents. Remember, it's inside out. 16 to the third, and then square root of that. Okay. We can change that a little bit. We can say the square root of 16 to the third power. That's the same thing. Well, the square root of 16 is 4 to the third, and 4 to the third is 64. Okay. Make it so that that way you don't need a calculator. You can kind of do it in your head. Okay, so again, inside out. So you have the third root of negative 8 squared is 64. And the third root of 64 is 4. Okay. Let's take a couple more here. All right, so you have 9x to the negative half and 4x to the negative 3 halves. And it looks like they already restrict our domain for us, which is nice. So the first thing we have to do is get rid of our negative exponents, and we also have to get rid of our fractional exponents. Okay, so what I want to do is I need to flip-flop this to the bottom, but here I just need to move the x to the top. So I have x to the 3 halves over 4 9 x to the half. Now, this is kind of where it gets a little bit difficult and a little bit different than what we've talked about before, because before I said you cannot distribute this exponent into these. But you also can't write this half number of times. What we could do is we could say that, and I'll do this up over here. Okay, the 9x to the half power as the square root of 9x. Okay. Well, what's the square root of 9? That's 3. And then what's square root of x? Well, that's to the half power. Okay, because we want to change it back to this power, right? We want them both to have powers. Okay, so that's similar to distributing, but it's a little bit different. Okay, I don't want you to think about it as just distributing that exponent. So we will have x to the 3 halves, 3 times 4, which is 12, x to the half. Now notice I have x's in the top and the bottom. Okay, now where are there more x's? Okay, well, there will be more x's in the top. This is 1.5, and this is a half. So there are more x's in the top, and in fact, there is just one more x in the top than the bottom. Again, you can subtract that. That's 3 over 2 minus a half. That's 2 over 2, which is 1. So here's 1. Okay, so we don't have any negative exponents. That's fine. But we do have this kind of power to a power. What we're going to do is we're going to think of it as the third root. So we have the third root of negative 8x squared y over, this is the square root of 9xy to the fourth. Root of 8 is minus 2, but your x's and y's don't have a third root. Okay, but remember from, let's see if I can find it. From one of the rules, we could split up this multiplication and take each one to its own root. Okay, so I'll have the third root of x squared, which is 2/3. And I'll have the third root of y, which is 1/3. The square root of 9 is 3. The square root of x doesn't reduce, but that's the half power. And the square root of y to the fourth is y squared. All right, so notice I have x's on top and bottom, and we just need to simplify those out. So in this case, we will have to subtract. I can't really tell where, or it's a little bit difficult. So we still have minus 2 on the top, 3 on the bottom. Okay, so then we have 2/3 minus a half. That's 2/3 minus a half. So you need a denominator of 6. So that is 4 over 6. And that is 3 over 6. So 4 minus, so that looks like 1/6 in the top. Okay. This you should be able to tell that there are more on the bottom. Okay. So we'll take 2 minus 1/3. Well, 2 is the same as 6/3. So 6 minus 1 is 5 over 3. And we're finished. You could write it, if you wanted, you could write negative 2 the 6th root of x, the third root of y to the 5th. You could write it like that if you truly wanted. That would be fine. Excuse me. All right. Last one here. We're factoring. We won't see a lot of these. And the only reason we really do this is so that we can deal with factoring and looking at fractional exponents. So if you look here, notice that 2/3 will go into each one of these. So I'm going to factor out an x to the 2/3. Okay. What is left? Well, 8 minus 2 will give you 6. 6 divided by 3 is 2, so you have x squared minus 5. 5/3 minus 2/3 is 3/3, which is 1, minus 6, because you're taking the whole thing out. So we factored out our greatest common factor, and now we need to factor this. So on your factors of 6, that's subtract of 5. 6 and 1, x. Signs are different. The bigger one is negative. And don't forget about rewriting your greatest common factor. X to the 2/3. Okay? That's it. I know that seems like it's pretty difficult, and it can be if you're not taking your time and really working them out. Okay, again, there are your suggested problems. Work them out. Work out as many as you can. If you got questions, see me before school. Definitely see me or ask somebody before you take the quiz. Okay, once you take the quiz, it's a done deal. Okay. As always, this is at THS. Please make sure to follow me on Twitter.